Welcome back, children. The next topic is combinations. Suppose in our class if there are three dancers X, Y and Z, three dances. For a competition I need a group of two students. So in how many ways I can do that selection? There are three dancers and I need two. So I can select either XY, a group, then or YZ or XZ. So this selection. So combination means it is just a selection. Here there are three objects. Three objects and taken how many? Two at a time. There are three objects taken two at a time. The notation is NCR. So NCR means number of combinations of n different objects taken are at a time. NPR, you know what is NPR? Number of permutations of n different objects taken are at a time. Permutation means it is an arrangement in a definite order. So their order is very important in permutation, but here order is not important. XY and YX both are same. It is just a selection. Their order is not important, but in permutation order is very important. Okay. So NPR is number of permutations of n objects taken are at a time. NCR is number of combinations of n different objects taken are at a time. Combination means just a selection of R from n. Here it is arrangement. Their order is important, here order is not important. Now how we relate this combination and permutation? So let us consider one example. Suppose we have 5 objects A, B, C, D, E, and I have to select 3. So in how many ways I can select 3 objects? Out of 5, 3 objects I have to select. So I can select A, B, C. One is A, B, C, or A, B, D, or A, B, C, A, B, D, A, B, E. Then I can select ACD, ACE, okay, then ADE, then BCD, BDE, BCD, BDE, then CDE, then one more, BCE. Okay, so ABC, ABD, ABE, ACD, ACE, ADE, BCD, BCE, BDE, CDE. So total 10 selections are possible. Now what are the number of permutations? Number of permutations of 5 objects taken 3 at a time. That we studied how to write 5 objects taken 3 at a time, 5p3. Number of permutations of 5 objects taken 3 at a time. How to calculate that? 5 factorial by 5 minus 3 factorial, or 5 factorial by 2 factorial. So 3 into 4 into 5. 5 4s are 20, 23s are 60. So NP3 or 5p3. 5p3 is 60. This is permutation. Their order is important. If I take A, B, C, then we can write A, C, B, then starting with B. These 3 letters itself we can change in so many ways. Okay, that's why the number is more in permutation. 5p3 is 60, but the selection, that is 5c3, is only 10. So permutation is more than the combination. Now what is the relation? How we get 5p3 from 5c3? What you want to do? 10 into 6 is 60. Into 6 means into this 3 factorial. Where is this 3? This one. Okay, so into r factorial you have to do. So look, theorem 5. NPR, number of permutations of n objects taken r at a time, is equal to NCR into r factorial, where r value is 0 less than r less than or equal to n. So it is understood from the previous example. Okay, so no need to write the proof, just you have to learn this. NPR is equal to NCR into r factorial. And NPR, how to write NPR? Factorial n by n minus r factorial, and NCR is equal to n minus r factorial. Take this r factorial to left side, so it is by r factorial. So this also you have to. NCR is equal to factorial n by n minus r factorial into r factorial. R is 0 less than r less than or equal to n. Now what is NC0? Some remarks are there. What is NC0? So using that result, NC0 is n factorial by n minus 0 factorial into 0 factorial. That is n factorial by n factorial, and 0 factorial is 1. So this is 1 itself. And what is NCN? Factorial n by n minus r factorial into r factorial. So this cancelled. 0 factorial is 1, so it is 1 itself. Now third one, NC1. NC1 is n factorial by n minus 1 factorial and 1 factorial. The term before n factorial is n minus 1 factorial into n by n minus 1 factorial. So it's cancelled and this is equal to n. Now the next result, NCN minus r. What is NCN minus r? NCN minus r is equal to factorial n by n minus r factorial into n minus r factorial. So this n and n cancel. So n factorial by minus of minus plus r factorial into n minus r factorial. That is same as NCR. So NCN minus r is equal to NCR. Okay. So from this we can deduce one result, that is if NCA is equal to NCB. Here look, NCN minus r and NCR are equal, but this n minus r and r not equal. Okay, so if NCA is equal to NCB, which implies either A is equal to B, sometimes A is equal to B, or what is the sum of n minus r plus r? That's equal to this n. Okay, so if NCA is equal to NCB, then either A equal to B, or we can say that A plus B is equal to. Okay, so this also important. Now we have one more theorem. NCR plus NCR minus 1 is equal to n plus 1 CR. So we can prove this taking LHS. NCR plus NCR minus 1. NCR is factorial n by r factorial n minus r factorial plus factorial n by r minus 1 factorial n minus r minus 1 factorial, or n factorial r factorial n minus r factorial plus n factorial, r minus 1 factorial, and n minus r plus 1 factorial. Now we can take common terms outside. So before that, n factorial is common, denominator. Here r minus 1. R is more than r minus 1. So r factorial we can write as r minus 1 factorial into r factorial. Okay. Then n minus r factorial plus n factorial. N minus r plus 1 is the next term of n minus r factorial, isn't it? So n minus r plus 1 factorial is n minus r factorial into next term. Now take common outside factorial n, r minus 1 factorial, n minus r factorial. Then in the bracket, here just r only, not r factorial. So 1 by r plus 1 by n minus r plus 1. Now solve the bracket. R minus 1 factorial into n minus r factorial, n minus r plus 1 plus r by r into plus 1. R and r cancel. Okay. So n plus 1 factorial, sorry, I'll write in the next step. N factorial into n plus 1 by, here don't multiply, we write together, that is r minus 1 factorial into r. So this we can combine and write factorial r. Like that, n minus r factorial into the next number. So we can write n factorial into n plus 1. Like 5 factorial into 6 is 6 factorial. So the same way, it is n plus 1 factorial by r factorial and n minus r plus 1 factorial. Okay. Now what is RHS? Taking RHS, n plus 1 CR. N plus 1 CR. So how to write n plus 1 CR? N plus 1 factorial by r factorial, this number, then n plus 1 minus r. That is n plus 1 factorial, r factorial, n minus r plus 1 factorial. Compare these two. Both are same. So LHS equal to RHS. So what is the result? NCR plus NCR minus 1 is n plus 1 CR. So NCR means number of combinations of n objects taken r at a time. Combination means it is just a selection. Order is not important. But for permutation, it is arrangement. Their order is important. NPR is the notation for that. Then NPR, number of permutations, is more than number of combinations. NCR is factorial n by r factorial into n minus r factorial. One more term in the denominator. In NPR, n factorial by n minus r factorial. That's why combination is smaller than the permutation. Okay. Then NC01, NCn is 1, NC1 is n. Then NCA equal to NCB means either A equal to B or A plus B is equal to n. Then NCR and NCn minus r both are same. Then this theorem. Okay.